Hello. For our next presentation, there was a problem, and what we are going to be playing a different talk instead. So the presentation that you're going to be seeing right now is called Retro: The Magic of Self by Sebastiaan Self. This is a recording, but if you have any question, please feel free to pause the questions here, and we will make sure to move these questions to make this question arrive to the speaker. Hope you are all having a really good conference, as I am. See you in a moment.
Hello everyone, thank you all for joining the stream. I was planning on wearing my pajamas today, but it's really cold in here, so I decided to put on this crazy sweater instead. Still, I really like the idea of having a lazy conference from the comfort of my own home. Anyway, today I'll be talking about self in Python, and in doing so, I will introduce something called the descriptor protocol. But first, I'm going to briefly introduce myself. I am Sebastiaan, and I live in the Netherlands. During the day, I work as a Python developer and codesmith for the Ordina Pythoneers. I'm also one of the 3 owners of Python Discord, an online Python community. Together with about 100 volunteers, we try to provide a safe and welcoming environment for Python enthusiasts. But we also do things like organizing Python-related events or helping out other organizations in the Python ecosystem. Finally, I'm also a volunteer for EuroPython, another very amazing Python conference. If you haven't already, you should definitely check it out in 2022. Alright, that's enough about myself. So let's dive into the magic of self in Python. I'd like to start with something that Guido van Rossum said on Twitter a while ago. In a conversation about Python's many magical features, Guido said that, from day one, there was deep magic hiding in some places, designed to quietly help users. And it's true. This is why people say that Python is a very high-level programming language. There's a lot of magic in Python that abstracts away those pesky implementation details so you, the end user of Python, can focus on your business logic. You get a lot of very high-level interfaces to play around with, and you rarely have to worry about the logic underneath that makes it all happen. Some of this magic is of the very arcane kind, the kind that you and I, mere mortals, don't really get to play with, as it's hidden away deep inside of Python's internals. But a lot of that magic is not. It's there for you and me to play around with and to create high-level interfaces of our own. Today, I'm going to dive into one of the most magical things in Python, that when you call a method, you get the value for self for free. Without doing anything, Python has magically inserted the thing you called the method on as the argument for self. By diving into the magic of self, I hope to show you that magic in Python is not something to be afraid of. That you can pick it up and use it to write better software of your own. So, what is the magic of self? To make sure that we're all on the same page, I'm going to implement a very simple class. The class itself is not going to be very exciting or thought-provoking or pretty much do anything interesting at all. It's only meant to illustrate what the magic of self is. As you can see, I have a very simple class called guitar. The only thing it does for now is that if you pass a name to it, the dunder init method will assign the attribute name to whatever name you gave the guitar. This means that if I call my class like this, here I'm using the name of one of my basses, Warwick Streamer, I get a guitar instance and I can assign a name to it. In this case, I'm assigning a name Warwick to it, as I think that's a name that nicely describes what it is. Now that I have a Warwick guitar instance, I can simply get its name by accessing the name attribute. So far, nothing really interesting is going on, so let's add another method to this class. The method that I'm adding is a plain note method that will mock the guitar playing a note, as actually playing a note on a guitar with Python is quite hard. Basically, I can call the method on a specific guitar, pass in the note I want to play as an argument, and Python will print the name of the guitar, place the note, followed by whatever note I passed in. So if I call this method on my Warwick bass, pass in the note C#, the musical note, not the programming language, and hit enter, Python will print out the message my Warwick streamer placed a note C#. Nothing special, right? Well, if we zoom in on the function definition of the plain note method, we can see that something odd is going on. I know that I'm so used to adding it that it's almost subconscious, and in fact my IDE mostly does it for me, but this function actually has two parameters, not just one. It has a parameter I've called self and a parameter I've called note. But if we now look at how I called the method, you can see that I only gave it one argument, and it's clear that that argument, C#, ended up with the parameter note. So where does the argument for self come from? If you call a function, all parameters without default values should get an argument. Is this some kind of special exception? In fact, it's not, but something magical is going on. What has happened is that Python automatically inserted the instance, my Warwick here, as the first positional argument when calling the function. And this is the magic of self. Somehow, without us having to do anything at all, Python will insert the instance you're calling the method on as the first argument. However, while you may think this is some deep arcane magic that Python just performs for you, there's actually a well-defined protocol behind it, the descriptor protocol, that you can use yourself as well. And that's what I'm going to talk about today. But first, I have to explain what happens when you define a function within a class body. What exactly are methods in Python? To understand what methods are, we have to look at what happens when you define a function within the body of a class. As everything in Python is an object, including classes, if you're defining a class, you're creating an object of type. I'm going to represent that class object by this rectangle. And just to be sure, with object I don't mean the potential guitar instances you could create with this class, but the actual class itself, the guitar class. Now let's zoom in on what happens when Python gets to the function definition of the plain note method. Once again, since everything is an object, Python will create another object for you, a function object, an instance of the type function that contains everything there is to know about this function, including the code it has to run when you call the function. Now, since we don't really have a use for objects that are just floating around somewhere in memory, without a name referring to them, a function definition will also bind a name to the function object. Since we are defining this function within the context of a class body, this name will not just be a regular name, but it will be an attribute of the guitar class. In this case, Python will bind the attribute plain note of the guitar class to the function object in memory. However, it is important to note that our method is still mostly just a regular function object. But if our method is just a regular function object, what on earth is going on with self then? One really important observation is that we've assigned a class attribute to the function object. This may look quite innocent. Why would it matter that it's a class attribute instead of a regular name? But this is actually an important aspect of the magic of self. And to see why, we need to look at what happens when we access that function object using an attribute. Since we've assigned a class attribute to the function object, we can access the method as an attribute of the class, guitar.playNote. If I do that, you'll notice that I simply get back the function object. This is just a normal function object. There's been no magical insertion of self yet. That makes sense, since we don't even have an instance to insert as the argument for self yet. We're just accessing it on the class itself. Now let's see what happens when we access the playNote method as an attribute of an instance. First, I'm going to recreate my Warwick instance, and then I'm going to access the playNote method as an attribute of the instance. If you think about that, it's a bit weird. I just made a big point of saying how we've assigned a class attribute to this function, and now I'm trying to access it as an attribute on a guitar instance. So what's going on here? Well, this has to do with the way attribute access works in Python. If you access an attribute on an object, like I'm trying to do now on my Warwick object, Python will first look at that object to see if it has that attribute. If it does not have that attribute, like how my Warwick does not have a play note attribute itself, Python will then move on and look at the class of the object. Does the class of the object have an attribute with that specific name? In this case, it does. But if it does not, Python will then look at all the other classes in the method resolution order, all the parents of the class, to see if they have such an attribute. So accessing an attribute isn't as simple as you might think. There's actually an entire lookup sequence behind it. And in fact, as we'll see now, what I just told you is a simplified version of what actually happens. Because if I now press enter and actually show you what accessing this attribute on the instance gets me, you'll see that I don't get the irregular function object back. Instead, I'm getting something called a bound method. And it's precisely this bound method that already knows what the value for self must be, the object you've used to access this bound method. So what is crucial here is the way in which we access the function. Did we use a class attribute or did we use an instance attribute? And this is because objects, like functions, can modify what happens when you access them via an attribute. They can hook into the attribute lookup process to modify what will happen by implementing something called the descriptor protocol. The descriptor protocol is what really powers the magic of self in Python. It allows objects to customize what happens when you get attributes, set attributes, and delete attributes. One important aspect of descriptors is that they're assigned to class attributes. So it's the object that you're trying to access that implements the protocol, not the class that owns the attribute. The descriptor protocol consists of three special or dunder methods. The dunder get method is involved in customizing attribute lookup, like simply accessing warwick.playNote. The dunder set method is involved in customizing attribute assigning, like if you assign something to warwick.playNote. And finally, the dunder delete method gets called when you delete the attribute that is assigned to the descriptor, like del warwick.playNote. Descriptors do not have to implement all the methods in the descriptor protocol. Instead, they can just implement the methods they need to do their work. As you've probably already guessed, functions are such descriptors. They implement the dunder get method to customize what happens when you get a function using an attribute. To get a better idea of how descriptors work, I'm now going to implement a simple descriptor that also customizes attribute lookup. For my example, I'm going to implement a descriptor for my guitar class. To make some room for it, I'm first going to collapse its methods, but you may assume that they're still there. The descriptor that I'm going to implement is the favorite descriptor. The idea is that if I access the isMyFavorite attribute on a specific guitar instance, this descriptor will tell me if that guitar happens to be my favorite guitar. For instance, if I recreate my Warwick instance and then access the isMyFavorite attribute on it, it should return true, as my Warwick bass is currently my favorite guitar. If, on the other hand, I create an instance for my Fender Jazz bass, the attribute should return false, as while this is a very nice bass guitar, it's currently not my favorite. Do note that I've assigned a class attribute to the actual descriptor instance, as this is how descriptors work. They customize how attributes work if you access them via an attribute. I'm not turning the guitar class itself into a descriptor. That wouldn't work. Alright, time to implement the descriptor class, favorite descriptor. Since I only want to do something special when we access the attribute isMyFavorite, I only have to implement one method, a dunder get method. The dunder get method has three parameters: self, which refers to the descriptor instance, instance, which refers to the current guitar instance I'm accessing the attribute on, like my Fender or my Warwick, and owner, which refers to the class that owns the attribute, guitar in this instance. Now, remember, I've assigned a class attribute to the descriptor. This means that in theory, I can also access the descriptor directly on the guitar class as guitar.isMyFavorite. Since there is no specific guitar instance in that case, Python will pass none as the value for instance. This is something that I will have to deal with, which I simply do by checking if the instance is none, and if so, by returning the descriptor itself. Returning the descriptor itself is not strictly necessary, but given that I have no other useful value to return, I might as well return a descriptor so you can easily introspect it. If the function makes it past this guarding if statement, I know that the attribute was accessed on an instance. So now I can simply compare the name of the instance to the name of my favorite guitar, Warwick Streamer. Obviously, this implementation is a bit naive in that it assumes that an instance always has a name attribute, but this is obviously just an example. Alright, let's see it in action. First, I recreate my Warwick instance. And then, when I access the isMyFavorite attribute on it, you will see that it returns true. What has happened is that Warwick was inserted as the argument for instance, and the guitar class as the argument for owner. Since instance isn't none, we make it past the first if statement and compare the name of the instance to Warwick Streamer. Since the name is Warwick Streamer, we get true. If I now also create an instance for my Fender Jazz Bass, you can see that when I access the attribute on my Fender, the attribute will return false, as the name of this guitar is not equal to Warwick Streamer. Finally, to complete the demonstration, if I access the attribute directly on the class, that is guitar.isMyFavorite, then I simply get the descriptor back. This is because there is no instance of the guitar class here, so Python will pass none for the instance. Which means that the function returns the descriptor itself in the if block that we have. Now, you might think that this is a really simplified example, that the dunderGet method of a function, the one that takes care of the magic of self, is much more complicated than this. In truth, as I'm about to show you, the dunderGet method of a function is nearly identical to the dunderGet method we have here. This is the implementation of the dunderGet method of functions, or well, a pseudo-implementation of the actual get method that was written in C. As you can see, it's nearly identical to what I just implemented for the favorite descriptor. If the instance is none, which happens if we get a function using a class attribute directly, this dunderGet method will simply return self, which here means the function itself. If we access the function on an instance, that instance will be passed as the argument for the instance parameter, which means that we make it past the if statement and then return something that is called a Py method. And this is the bound method we saw earlier. First, I recreate my Warwick instance. And then, when I access the isMyFavorite attribute on it, you will see that it returns true. What has happened is that Warwick was inserted as the argument for instance, and the guitar class as the argument for owner. Since instance isn't none, we make it past the first if statement and compare the name of the instance. Since the name is Warwick Streamer. Alright, let's see it in action. Hello everyone, thank you all for joining this stream. I was planning on First, I recreate my Warwick instance. And then, when I access the isMyFavorite attribute on it, you will see that it returns true. What has happened is that Warwick was inserted as the argument for instance, and the guitar class as the argument for owner. Since instance isn't none, we make it past the first if statement and compare the name of the instance to Warwick Streamer. Since the name is Warwick Streamer, we get true. If I now also create an instance for my Fender Jazz Bass, you can see that when I access the attribute on my Fender, the attribute will return false, as the name of this guitar is not equal to Warwick Streamer. Finally, to complete the demonstration, if I access the attribute directly on the class, that is guitar.isMyFavorite, then I simply get the descriptor back. This is because there is no instance of the guitar class here, so Python will pass none for the instance. Which means that the function returns the descriptor itself in the if block that we have. Now, you might think that this is a really simplified example, that the dunderGet method of a function, the one that takes care of the magic of self, is much more complicated than this. In truth, as I'm about to show you, the dunderGet method of a function is nearly identical to the dunderGet method we have here. This is the implementation of the dunderGet method of functions, or well, a pseudo-implementation of the actual get method that was written in C. As you can see, it's nearly identical to what I just implemented for the favorite descriptor. If the instance is none, which happens if we get a function using a class attribute directly, this dunderGet method will simply return self, which here means the function itself. If we access the function on an instance, that instance will be passed as the argument for the instance parameter, which means that we make it pass the if statement and then return something that is called a Py method. And this is the bound method we saw earlier. When it gets created, it gets the function as we pass self to it, and it gets the instance as we pass the instance parameter to it. And that is how a bound method already knows which instance it is bound to. It happens when the function is accessed. To show that in action, if I access the playNote method directly on the class, there is no instance, so instance will be none in the dunderGet method, and we will just get the function itself back. This is because accessing it in this way is more or less equivalent to calling the function's dunderGet method directly and passing none for the instance parameter and the guitar class for the owner parameter. Likewise, if I recreate my Warwick instance and access the method on that, we get a bound method back. This is because this is roughly equivalent to calling the function's dunderGet method directly, with Warwick as the value for instance and guitar as the value for owner. And this is the magic of self. When you access a function using an attribute, the descriptor protocol takes care of binding the instance to the function in something called a bound method. And functions are not the only descriptors that are built into Python. There are some other built-in descriptors that you've probably already used, potentially without knowing that they make use of the descriptor protocol. I'm going to show you 3 other built-in descriptors that you've probably already come across. First, the class method descriptor, which is often used as a decorator, wraps around the function to bind the class and not the instance to the function. It does this by implementing an alternative dunderGet method that binds the owner parameter instead of the instance parameter to the function. One difference with a regular function is that this binding happens both if you access it on an instance as well as when you access it directly on the owner class. Likewise, the static method descriptor also wraps around the function to provide an alternative dunderGet method. This dunderGet method will not bind anything at all, but will just return the function as is, even if you access it on an instance. And finally, the property descriptor, also often used as a decorator, allows you to easily create getters, setters, and deleters. It does that by calling the methods you specified in its dunderGet, set, and delete methods. And with those descriptors, we've come to the end of my talk. To summarize, the most important 2 takeaways are: 1. Descriptors allow you to customize attribute access, which means that you can abstract away logic behind the normal flow of interacting with attributes. And 2. This is precisely what functions do. They are descriptors that modify attribute access to create bound methods. There are also a number of important things that I haven't covered in this talk. First, I haven't really talked about dunderSet and the dunderDelete methods. These are important, as the presence of these methods in a descriptor actually influences the lookup sequence Python uses. Descriptors with a dunder set or a dunder delete method are what the docs call data descriptors. A descriptor with just a dunder get method is called a non-data descriptor. Since this distinction can be tricky to get, I recommend you to look it up in a good resource, like Raymond Hettinger's tutorial on descriptors, or in a book such as Fluent Python, which calls them overriding and non-overriding descriptors. Finally, I also haven't mentioned the dunder set name method. While this method is technically not a part of the descriptor protocol, it is often used within descriptors to get access to the name of the attribute that was assigned to the descriptor. I'd like to end my talk with a quote from Lee Siegel. "I'm writing a book on magic," I explain, and I'm asked, "Real magic?" By real magic, people mean miracles, thaumaturgical acts, and supernatural powers. No, I answer, conjuring tricks, not real magic. Real magic, in other words, refers to the magic that is not real, while the magic that is real, that can actually be done, is not real magic. There is a lot of magic in Python, and some of it is of the deeply arcane kind that we, mere mortals, cannot really touch, as it's hidden away deep in Python's internals. At the same time, most of the magic in Python is of the kind that we can use, that we can hook into. In this talk, I've zoomed in on a particular piece of magic, self, but I would like to challenge you to go out there and dive deeper into Python's data model, to discover even more magic and to use that magic to create meaningful abstractions and objects that behave just like Python's built-in objects do, to provide the users of your code, including yourself, with a high-level interface that is familiar and that makes sense. So, go out there and practice magic. With Python, we can all be magicians. This is it. I hope you've enjoyed it. If you want to take another look at the slides of this talk, you can find them on my website, sebastiaanzeeff.nl. You can also follow me on Twitter or connect with me on LinkedIn. You can also often find me on Python Discord as Sebastiaan. In any case, thank you for your attention, and I hope that you'll enjoy the remainder of Pyjamas.